Good morning, everyone. Welcome back to my channel. So my name is Arijit, and this is our fourth session related to SCM Analytics. So today we are going to see how to create a model from a transportation issue. So let me share my screen. All right. I hope that you are able to see my Excel file. So this is the transportation problem. And considering all these factors, the input parameters and the constants, we are going to find the best possible solution. And what is our objective for this problem? The objective is we need to fulfill the customer demand. What is the customer demand? So these are the customer demands. So basically, we have four customers, customer 1, 2, 3, 4. And these are the demands of each of the customers. So the demand of customer 1 is 50. The demand of customer 2 is 10. The demand of customer 3 is 70. And demand of customer 4 is 30. Okay. And what is the objective? To fulfill the customer demands, but minimize the transportation cost. So we need to minimize the transportation cost. Now, what is the transportation cost? To to carry the materials from distribution center 1 to customer 1, the transportation cost is 9 rupees per ton. Okay. So you can see here, for transporting coal from DC1 to customer 1, DC means the distribution center. Okay. Cost per ton is 9 rupees. Cost per ton is 9 rupees to transport the coal from DC1 to customer 1. Likewise, from DC1 to customer 2, it's 6 rupees per ton and so forth. So, to transport the coal from DC1 to customer 2, what is the transportation cost? 6 rupees per ton. To transport the coal from DC1 to customer 3, the transportation cost is 3 rupees per ton. From DC1 to customer 4, what is the transportation cost? The transportation cost is 2 rupees per ton. Okay. And what is the supply capacity? The supply capacity of DC1 is 50 ton. That means DC1 can only supply up to 50 ton per day. Okay, so this will be one of the constraint, and we need to keep in mind while solving this transportation issue. Okay, so if I say for the DC2 also, to transport the coal from DC2 to customer 1, the cost is 8 rupees per ton. From DC2 to customer 2, that is 6 rupees per ton. Likewise, 7 rupees per ton for transporting the coal from DC2 to customer 3. And to transport it from DC2 to customer 4, that is 4 rupees per ton. And what is the supply capacity? The maximum supply capacity of DC2 is 35 ton per day. Okay. Now, you can consider for DC3 as well. For DC3, from DC3 to customer 1, the cost is 10 rupees per ton, 8 rupees per ton from DC3 to customer 2. From DC3 to customer 3, that is 20 rupees per ton. And from DC3 to customer 4, that is the cost is 8 rupees per ton. Okay. Now, what is the objective? The objective is to fulfill the customer demand by minimize the transportation cost. So as of now, whatever the problem we saw in our previous classes, what was the objective? The objective was to maximize the profit. So here we have created a model where we maximize the profit. Similarly, in our first session also, we solved one problem, which is also, what is the objective of that problem? The objective of that problem also was to find out the maximum profit. Okay. But here, we need to find out what is the minimum transportation cost by keeping all these things in mind. And what are the things we need to keep in mind? What is the supply capacity of the DCs? What are the demands of these customers? And what are the cost per ton to carry out these materials from all these DCs to the customers? Okay. So let us formulate the mathematical model first of all. Mathematical model. Okay, so this is distribution center 1, distribution center 2, and distribution center 3. These are nothing but the source, right? So these are nothing, but we can call them as a source, correct? And this customer 1 to 4, these are nothing, but we can call them as a destination, right? Okay. Now, for the sake of creating this mathematical model, we are denoting these cells as X. Let's consider all these cells, as X. Okay. Let's consider all these cells as X. Now, we are going to refer first cell as 1, 1. Okay. So we are going to refer this cell as a 1, 1. The next cell we are going to refer as X12. X12. The next cell we are going to refer as X13. X14. Okay. So X that we have denoted for this cell, and from where we have mentioned this X11. So 1 stand for the source. And what is the source? The source is distribution center 1. That is why we have mentioned 1. And what is the destination? The destination is customer 1. So that is why we have mentioned 1. So we can denote this cell as X11. Okay. Now what is the next cell? We have denoted the next cell as X12. Now 1 stands for the distribution center 1, that is the source, and 2 stands for the destination, that is customer number 2. Okay, so that is why we have referred this cell as X12. The third one, X13. So again, 1 comes from the distribution center 1, that is the source, and the destination is customer 3. So that is why we have mentioned this as a 3. So the entire cell we have referred as X13. For the fourth one, we have mentioned X14. So 1 stands for distribution center 1, 4 stands for customer 4. So that is why we have referred this cell as a X14. Similarly, for the next one, we can mention X21. Okay, X21, X22, X23, X24. Okay, so X, we have denoted the entire cell as a X. Now, where from this 2 comes from? Again, that is from the source. And what is the source? The source is distribution center 2. So that is why we have mentioned is 2. And what is 1? 1 stands for the destination. That is, in our case, customer 1. So that is why we have denoted it as 1. So we can refer this cell as X21. Similarly, for this one, that will be 2, 2, because distribution center is 2 and the customer number is 2. What is the third cell? The third cell we can denote as X23. 2 stands for distribution center 2, 3 stands for customer number 3, and the last one is X24. Similarly, for the distribution center 3, for this cell 10, we can denote the cell as X31. Okay. Similarly, for the next one, that will be x32, x33, x34. So here 3 stands for distribution center 3, that is the source, and 1 stands for the destination, that is customer 1. So that is why we refer this cell as x31. Similarly, this is x32, x33, and x34. Okay, so let me just delete this data. Okay, now, so first of all, we will see what are our constraints. So constraint number 1, what is the constraint number 1? We need to fulfill the customer demands. So what are the customer demands? For customer 1, the customer demand is 50. For 2 is 10. For customer 3, that is 70. And for customer 4 is 30. So first constraint is demand constraint. Demand. Okay. So what is the demand? We can write it as x11 plus x21 plus x31 less than equal to how much? 50. Sorry, we need to fulfill the demand. That means that needs to be equal to 50. Okay. So what is x11? This cell is the x11 because the distribution center is 1 and customer 1 is 1. So that is why we have denoted this cell as 11. Correct? We have referred this entire cell as x, and this one we have referred as x11. This one is x21. Why? Because the distribution center is 2 and the customer is 1. That is why it is x21 and this is x31. So x11 plus x21 plus x31 needs to be equal to the demand. What is the demand of customer 1? That is 50. So we have mentioned the same thing. Similarly, for the customer 2, we can mention x12. What is 12? This is the 12, distribution center 1 and customer number 2, plus x22 plus x32 equal to how much? 10. So x12 is what? 1 is the source, that is distribution center 1, and 2 is what? The destination, that is customer 2. This one needs to be x2 and 2. So we have mentioned here x22, and this one needs to be x32. So that's why we have mentioned here as x3 needs to be equal to 10. So for customer number 3, we will do the same thing. x13 plus x, how much? This is 13. This needs to be 23 plus x33. This is the 33 equal to how much? 70. Okay. So this is the 13. Distribution center 1, customer 3. This is 2, 3. And this is 3, 3. So x13 plus 23 plus 33. So for customer number 4, we need to mention x14 plus this is x14. This is 1, this is 4. This will be x24 plus this will be x34 equal to how much? 30. So this is the mathematical model for the demand constraint. Okay. 50, 10, 70, 30, 50, 10, 70, 30. Okay, now what is the another constraint? The another constraint we need to keep in mind that what is the supply capacity of each distribution center. So what is the supply capacity? So this will be our supply constraint. Supply capacity is x11 plus x12 plus x13 plus x14 should be less than equal to 50, right? Now what is x11? X11 is this one, distribution center 1, customer 1. This will be x12. This source is 1, destination is 1, that is distribution center 1 and the customer 2. So that becomes x12. This will be x13. This will be x14. Okay, and that needs to be equal to 50 because 50 is the supply capacity of distribution 1 per day. Okay, similarly for this distribution center we can write x21 plus x22 plus x23 plus x24, right, less than equal to how much? 35. Similarly for distribution 3 we can write it down x31 plus x32 plus x33 plus x34 less than equal to how much? 35. Now what is 21, 22, 23, 24? This is x21, distribution center 2, customer 1. This is 22, distribution center 2, customer 2. This is 23. This is 23. This is the distribution center and this is customer 3. That is why we have referred this cell as a x23 and this is x24, right? Similarly for the distribution center 3, this cell we have referred as a x31, x32, x33 and x34 needs to be less than equal to the supply capacity of distribution center 3. So for what is the supply capacity of distribution center 3? That is 35. That is why we have mentioned here as a 35. So we have formulated the mathematical model for both the constraint as of now. One is the demand constraint and the second one is the supply constraint. Okay. Now what is our objective here? Objective is to minimize the cost. To minimize the cost. The cost, right? So what will be the formula of the objective constraint? The formula will be mean what is the cost for this cell? The cost is 9, the transportation cost. Okay, and what is how we are referring this cell? We are referring this cell as x11. So we need to mention here 9x11 plus what is the cost of this cell? The cost of this cell is 6. Okay, and we are noting this cell as what? We are noting this cell as x1, 2. One is source, 2 is destination. So here we need to mention x12 plus for this cell that needs to be 3 x13 plus, for this one we need to mention what? 2 x14 plus, for this cell we need to mention what? For distribution center 2 customer 1 we need to mention 8, then x21 plus, for this one we need to mention 6 x22, this one will be 7 x23 plus, this one will be 4 x24 plus, for distribution center 3 that will be 10 x31 plus 8 x32 plus, this one will be 20 x33 plus, this one 8 x34. Okay, so that becomes the mathematical formula for our objective function. Okay, so basically what we are trying to do in our objective function is like, the cost needs to be multiplied with the quantity that will go from distribution center 1 to customer 1. So for an example, so let me just repeat this model once again. Okay, so for an example, for distribution center 1, we are transferring coal of 10 ton to customer 1. To customer 2, we are transferring around 6 ton. Customer 3, we are transferring around 9 ton. And to customer 4, we are transporting around 4 ton of coal from distribution center 1. So for in this case, what will be the cost? The cost will become, first of all, how much ton we have supplied from distribution center 1 to customer 1? That is 10 ton of coal. And what is the cost to transport that coal from distribution center to customer 1? That is 9 rupees per ton. So we can multiply it with 9. Correct? Okay. Similarly, how much ton of coal we transport from DC1 to customer 2? That is 6. That is we can mention here as a 6. Multiply to it. What is the cost to transport that coal from DC1 to customer 2? That is also 6. Then we can mention 6 into 6 plus, how much coal we have transport from distribution center 1 to customer 3? That is 9. So here we can mention 9, multiply to it. What is the cost to transport that coal from DC1 to customer 3? That is 3 per ton. Then we can mention here as 3 plus, how much coal we have transport from DC1 to customer 4? That is 4 ton of coal, right? Multiply to it. What is the cost to transport that coal from DC1 to customer 4? That is 2 rupees per ton. Then we can mention here 2 rupees. And here we are going to find it out what? Here we are going to find it out the minimum cost. Minimum cost. So this becomes our objective. So the same formula I have mentioned here. Okay, so this will be our objective formula based on mathematical model. Okay. So I hope that you are able to understand that how to create a mathematical model from the English language. Okay. Now we are going to directly solve this problem using Excel solver. Okay. So let me write it down. Constant. Constant. So first of all, demand. First of all, demand. Constant. Okay. So what is the demand constant? We have already mentioned here. Same thing we are going to formulate here also. So demand constant is this one plus this one plus this one less than, sorry, equal to how much? 50. 50. Okay. For customer 2, this 3 equal to how much? 10. For customer 3, equal to how much? 70. For customer 4, thirty. So we have formulated all the demand constraints. So basically we need to fulfill this demand. Okay. For customer 1, 2, 3, 4, you can see we have just changed the mathematical model to what? We have changed the mathematical model to formula so that we can solve this problem by using the Excel solver. Okay. Now let me add the supply constant as well. So as per mathematical model, what is the supply constant? X12, this is the one. X11. So X11, this is the cell. X12, this is the one. X13 plus X14 should be less than equals to how much? Supply capacity of DC1. Okay. So let me formulate the same formula. Sum this entire for X11 plus X12 plus X13 plus X14. Okay. Less than equals to how much? 50. So let me get 50. Similarly for DC2, that needs to be this one, less than equals to how much? 35. For the third one, this is the one, less than equals to how much? 35. Okay. So I have formulated all the demand and the supply constraint. Now, what will be the OFB formula? Let me formulate that OFB formula as well. So here in the mathematical model, we have already found out what will be the uh, formula for the objective function. Okay. So what will be the objective function? So basically, whatever we discussed as of now, we can mention quantity transferred from DC1 to customer 1. That means this cell multiplied with cost of transferring that coal from DC1 to customer 1 per ton, that is 9 rupees in our problem. So this one, okay, plus the quantity that we are going to transfer from DC1 to customer 2, that is this cell, multiplied with the cost of transporting that coal from DC1 to customer 2, that is 6 rupees in our problem. That means this cell. So I am adding this cell, okay, plus the quantity of customer 3 that we are going to transport from DC1, we need to select this cell, multiplied with the cost of transporting that coal from DC1 to customer 3. That means we need to select this one, which is 3 rupees per ton in our problem. Plus, likewise, we need to go up to this cell. Okay. Likewise, we need to go up to which cell? This cell. So this cell means what? Quantity of distribution, quantity that we are going to transport from DC3 to customer 4. That means we need to select this one, multiplied with the cost of transporting that material from DC3 to customer 4. That is in our problem, it's 8 rupees per ton. So likewise, we can go one by one. Otherwise, what we can do, thanks to Excel, we have a inbuilt function is there. So we can use some product. Okay. So when you use some product, select all the quantities from DC1 to DC3 that we are going to supply to each of these customer. That will become your first array, comma. All the cost that you are going to incur to transport those materials from all these DCs to the customer, select this array. That is you need to select from rupees 9 to rupees 8 in our problem. Close the bracket. Now this will become your OFB formula. Okay, so this is your OFB, and this will be your decision variables. This will be your decision variables. Okay, so basically we are going to find it out the quantity that we can supply from DC1 to all these customers, from DC1, DC2 or DC3 to all these customers, considering all these constraints that we have already formulated, so that we can able to minimize the transportation cost. Okay, so today we are not going to try that heuristic approach or the graphical method. We are simply going to solve this issue by using the Excel solver. So let me just go to the data, click the solver. Let me just reset it. Okay. So what is our objective? To minimize the profit. To minimize the transportation cost. So here we have already formulated the formula. We are going to select this one. Okay. Here we need to select the minimum because our objective is to minimize the transportation cost, not to maximize the transportation cost. So here we are going to select the mean. By changing the variables here. So what are our decision variables? These are our decision variables because we need to find out that what is the quantity, what are the quantities that we can transport from all these DCs to these individual customers. Okay, so I am selecting from here to here. That will be our decision variables. Okay, now what are the constraints? So these are our constraint. So first of all, let me add this constraint. Okay, and that needs to be equal to these numbers. So these are our demand constant. Let me add the supply constant as well. So these are our supply constant. Less than equal to, these are the numbers. Okay, click on add. So again, we are not going to supply any negative quantities to any one of these customers. So basically, you need to tick this option, make unconstant variables non-negative. Okay, so I am keeping these things as ticked only. Now again, we are going to solve this problem by using the simplex LP because this is a linear problem. Now, what do you mean by the linear problem? So that we have already discussed in our previous classes. If the variable power is one throughout these models, then you can consider that problem as a linear problem. So here you can see x, whatever we have mentioned here as a part of the mathematical model, the power of these variables are one only, right, throughout this model. So that is why we need to consider this as a linear problem. And if that is a linear problem, then what is the algorithm we are going to use? The algorithm we are going to use is simplex LP. Okay, now simply click on the solve button, click on OK. So this is your minimum transportation cost that we are getting per day. What is the minimum transportation cost? 890 rupees. And from distribution center, we need to supply 15 ton of coal to customer 1, 10 ton of coal from DC1 to customer 2, 25 ton of coal from DC1 to customer 3, and to customer 4, we are not supplying anything to customer from DC1. Now, if you want to cross check whether our model meet all the requirements or not, so we can cross check from here only. So for an example, for customer 1, the demand was 50 ton and we are supplying 50 ton. So this is fine. For customer number 2 also, the demand was 10 ton per day and we are supplying 10 ton per day. For customer number 3, we are not able to meet the demands requirement. The demand was 70, but we are only able to supply 30 ton. So here is an issue. So here we are going to discuss why we fell short for the customer 3. For customer 4, the demand was 30 and we are supplying 30 ton. So that is fine. If we check our model from supply perspective also, for DC1, the supply capacity was 50 ton and we are exactly supplying 50 ton. For DC2 and DC3 also, the supply capacity was 35 and we are supplying 35. So there is no issue in terms of supply perspective. Now, if we come to this one, that why our model not able to satisfy this condition, then let's understand one thing. What is our total supply capacity? Total supply capacity per day for us is these three, DC1, 2, and 3. And we can only able to supply 120 ton per day. Okay. And what is our total demand as per this problem? Total demand per day is this 4. Okay. So our total demand per day is 160 ton. Okay. So we have a short of 40 ton of coal per day. Now, how we can increase our supply capacity? We can increase our supply capacity by increasing the distribution center. As of now, we have 3 distribution center. We can increase the distribution center by another 1 and we can supply this short 40 ton. Otherwise, our second option would be to increase the supply capacity of any of these distribution center. So for an example, if I increase the supply capacity of DC1 from 50 to 90, we can able to meet the demand of 40 ton. So now you can able to see our supply capacity increased to 160 ton and total demand increased and total demand remains same 160 ton. That means we can meet the demand per day. Okay, so let me apply this thing in Excel solver as well. So as I have increased the supply capacity of DC1 from 50 to 90, here also we are going to increase the supply capacity of DC1 from 50 to 90. Okay, so let me rerun the Excel solver once again. So here we do not need to select anything. It will come up automatically because we have already selected the entire details. Just click on solve. Okay, now you can able to see we are meeting the demand for all the 4 customers, including customer 3. And we are also keeping the supply capacity in mind while meeting up the demand. Okay, so as per this model, if we go, then from DC1, we are supplying 70 ton of coal to customer 3 and 20 ton of coal to customer 4 from DC1. From DC2, we are supplying 15 ton to customer 1, 10 ton to customer 2, and 10 ton to customer 4. And from DC3, we are supplying 35 ton to customer 1, and there is no other supplies to any one of these customers. Okay. And what is the minimum transportation cost that we are getting? The minimum transportation cost is 820 rupees. Okay. I hope that you have enjoyed today's class. So today we have resolved the transportation problem, first of all, by building a mathematical model and then by using the Excel solver. In our next class, we are going to solve some more issues related to production planning and also the transportation so that we can able to get some grip on those. Till then, bye and see you in the next class.